Welcome back to our channel. So today I will show you easy way of how to use computational softwares to accelerate your workflows. We'll be trying to do with grasshopper. This is a package that comes with rhinoceros, popularly called rhino. We'll also, in the next section, we'll also use dynamo. So today it's like an introduction to computation. We write scripts. Let me expand this. We write scripts to help you achieve a lot. So I'll give you a preamble to this. As structural engineers, civil engineers, architects, and so on, we tend to do a lot of what we call case scenario or design options. You could easily, or it is accepted that changes is constant in the design process, even to the construction process. We could see or encounter challenges as our site or some constraint which we have to come back to make some changes. And traditional way of is probably starting all over again or starting at a very far point, trying to get back to where you need. Or if, say, in the design process you are still trying to check between efficiency, cost efficiency, structural reliability, and aesthetics, the architectural performance or beauty, as the case may be. So we normally do lots of changes to our designs. So what these tools help us to do is to be able to make a change and then get our output as quickly as possible. All this, you can see all this, call these notes, they're all interrelated with these links. So if I make, let me show you. So I'm going to show you this. So the ad, see, I could design a portal frame and I'm checking, or go ahead and I'll show you how to create this using grasshopper. So before you start, open it. Open the new. Make sure the template you're using is in millimeter, because you're doing a large, not so large, but for this, so you can click check it here to check the unit of drawing. It's in millimeters. Launch your grasshopper. We'll create new one. New document. Well, first create a point. Go to parameter point. So this part created will have to be assigned in rhino. So you can double click here to come back to this and double click to get back to this view. I'll have to zoom in, take point, single point, single point, location of coordinate 0, 0, enter. Come over here, set one point, click on this point and set to that. Resize this. Go over to vector. We choose deconstruct point. So the point we've chosen has no coordinate, or has all the coordinates compressed into one. So we have to deconstruct this point to different coordinate. So we'll take this, link it. To unlink, you can hold your shift, your control to unlink. Hold your control to unlink. You can link it. So if we will take a number slider, what we are going to do right now is to create a number slider, or you could left click twice and put in the number and you get a number slider. Open it, name it, we'll call it wall height. We'll make it an integer number, maximum, let's say 24 meters. This becomes our wall height. You can resize this down. Check this, and we go to math and addition. We get this parameter addition. Our wall height is on our z direction, so we've created a point. We just constructed this point for the different coordinates, so I have to reconstruct it back. Construct point, take S and Y. We need our Z to have a new Z value. We get this. Now we can then change this. You can see our point is changing. We zoom out. You can see our point is changing. So we'll leave this here. I will then create a line joining these 2 points together. Go to curve line. So we need 2 points A, point A, and then end point B. So the point away from our point which we assigned, and the new point which we've moved to a certain height. So we got now our first line. This is like our first member. So we want to move this to a certain length or breadth. So we'll call it. Let us get a number slider. Enter. Double click. Call this width. And say let this be. This should be 24 meter. This wall height, we'll say 9 or 10. And these are just assumptions for you to get the basis of how it works. Get to vector. Easy way of searching is you right click to search and you're writing what you're looking for. So you are looking for a vector. This vector. The vector having its coordinates or its direction. Get this. Where do you want this to translate to? So this will be in the y-axis, or also be in the s-axis. So I'll take this, I'll connect this to x-axis. Tapping move, you can get this move in our transform folder. So move, you get it in under this move, mirror, move away from, rotate, you can get in there. So we can, this is our translation vector. We're moving this line to this point. So it has moved to this point. Now rotate this. You can change this. With your control, orient it whichever direction best suits your need. So we'll leave it here. We'll work with this. You can see. So let's work with it in this y direction. We've moved these points to this point. So we can arrange it. This is the top, bottom, and the member line. Top, bottom, member line. You can top point. So call this bottom point. I'll call this the member one. I'll call it member one. So the next one I want to create is with our apex point. So to create this apex point, we'll need it to be at the center of the distance between this point to this point. So on that note, we'll go to our math and take divide. Before we use this, we have to take what we call go to our vector and we deconstruct this point one more time. This point, we need the eyepiece to be on the top side, so we're going to deconstruct this point. So math subtract this is being a y-axis. Divide by 2. Reconstruct this point and this point. So we need another slider. And then apex height. Say 4,000. Okay, so this to sell to we'll now take this. So we are adding this. Okay, let me show you this. So connecting this to this, is with reference to this line at the bottom. So we just move 2 meters. Then best I'll show you using this. So we just move 3 meters, 2.2 meters above the ground. So to consider this, to reference it from this height, you have to take this point, which is this point from here. From this side will be plus 2.2, so plus from this distance. So connecting this to this, so this is now plus 2 from the height of this. So if we reduce it to 0, you see, anything we move to the height in respect to the height of this. So we have to create a line joining this to this. So head over to curve line. So we need 2 points. We have a point at the apex. We also need another point. So take from this point to this point. This point will be our first point, and this will be our end point. You can copy this with your Ctrl C, Ctrl V. If copy this. So we still need this point, then we need our next point. So our next point will be this point from here to here. So we check this now. Take this from here to here. So we connect this point to this point. And we've gotten our simple portal frame. So we've gotten our simple 2D portal frame. With this, you can do a simple 2D analysis of this portal frame. So the next in line to turn this to 3D to look like what we have to do what we call a series copy in sequence. And we have to take this at different intervals. So we need a copy of this in, say, in 5 meters interval with the number of copies we need. So that is the next thing we are going to do right now. So let's just get our points. So easier for us to remember. So we need, we have 3 points at the top. So consider those 3 points at the top. So take this point, we'll connect it to this point. So this point is this. We'll take this point and we'll connect it to this. So this point becomes this. Then we'll take this point and we'll connect it to this. So this point becomes this. Now we'll do the same for the lines. So we'll get a line. We'll take this line. We'll take this line. We'll connect it to this. We'll take this line, hold it down shift, we join it to this. I'll take this line, hold it down shift to join it to this. Then you see have one more line, and that will be this line. I'll take hold it down shift and join it to this. So we'll now have our members as one line. We have our points. So do our copy or series copy. So go to transform, choose our move tool. Choose it again and again, because I'm going to move these 3 points. Get this, we connect this to this, connect this and this. Our motion, our translation vector will be moving in the Y, in the S axis. Moving S axis. So for us to get that, we will have to get what we call a sequence series. That should be under sets. We have this. Let's push this forward, 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 forward. So we can have room for this here. So this will start from point 0. We need steps and we need count. So we'll create 2 number slider. And we'll rename. We'll call this our front spacing. And our spacing will be our maximum spacing. Let's assume it's meters, or let's just make it 10 meters. Okay, let's call this slider. Just rename it to a number of frames. Let's say 10 could be okay. So connect this to this number of frames and our count, the number of frame spacing to our steps. So our frame spacing will say 5000. You can click on it, or you can just navigate from here. Say 5000. So we have this. So if we check this, we'll move it put it here. We have an error, but this has all the coordinates lumped into one, or has no coordinates lumped into one, or has no coordinates. So first of all, we want to create a vector, because you have to translate this in a direction or not into an axis. So we get what we call the vector XYZ, which is direction or component. We get this, and we want this to be translated in the S direction. Now we get this vector component and put them into each and every one, and you can see we are copying this in sequence. You can increase the number of counts and reduce it, so 5 can be okay. So we have to join our lines or copy our lines too. So move our lines. Let's get our move to move it in this same vector in the S direction. As you can see, so this is having how rhino or grasshopper sees it, taking this as different values and trying to move it as one separately and as one. So what we can do is we can graft this data into these separate components. So we've grafted it and it has been able to resolve this perfectly. Then let's just see what we've created. As you can see, everything is still working alright. Okay. So the next thing will be to join our points. So we need the member running from each to each of these points. So we get what we call, we need a line, then we'll first of all have to shoot this line or the list. We have a beginning and an ending. So we take this and we connect it to this line. Also take a line so this could be our start, and this should be our ending. So taking this I'm taking this as our ending of cutting our line, reducing shift list, and take this to this. I need a line, connect this to this, and this comes to this, so we can have a starting and an ending point. Do same, shift list, line, this to this, this to this, and this to this. So there goes it. We've created your first photo from using computational. Using computations. For I made mistake by computational analysis. Using computations. So we created your first photo from using computation. We've written some codes. So our graphical codes. For it to follow. So let us flex this and see if what we created follows our logic. See the width, can increase the width, or apex height, can reduce it. The flat roof, can increase it. Can have to 3000. Wall height, can say 9000, and width you can make it 15 or 16. Let me have the height, and we have this. Thank you. And the next session will show you how to do this with Dynamo. So Dynamo comes with Revit. Thank you. Kindly subscribe to our channel, like, share, and turn on the notification bell.